Air quality has long been a pressing concern in urban development. At the start of the 21st century, China's rapid economic growth paralleled increasing air pollution issues in Beijing, raising national awareness about urban air quality. However, over the past decade, Beijing's air quality has significantly improved, as evidenced by a consistent annual decrease in the air quality index, without negatively impacting economic growth. This raised our curiosity about the air quality pattern in Beijing and the reasons behind. Was this improvement accomplished manually? If so, how did Beijing do it? Can the methods be replicated in other developing cities? We will analyze and present the air quality transformation in Beijing from both natural and manual aspects using big data. Beijing's air quality is influenced by climate factors. Annually, air quality patterns show that particulate matter, sulfur dioxide, nitrogen dioxide, and carbon monoxide levels peak in winter, while ozone concentrations are higher in summer. This is due to Beijing's temperate monsoon climate, which brings hot rainy summers and cold dry winters. Air composition changes with temperature and humidity fluctuations. In winter, the cold dry air descends near the ground, keeping the primary pollutants lingering. In summer, the high temperature chemically promotes the generation of ozone. Geographically, Beijing is surrounded by mountains on three sides and often experiences valley wind and sea breezes. This topography leads to pollutant convergence in the plains and at the mountain fronts. Data shows that the air quality in southern Beijing, which has a higher population density and industrial activity, is worse than in the northern part, characterized by mountainous terrain, low population density, and high vegetation cover. Faced with these natural challenges and the growing life and industrial emissions, the Beijing government has implemented a series of policies that effectively improve the air quality. A report published by UNEP named A Review of 20 Years Air Pollution Control in Beijing reveals the effort made by the Beijing government, which mainly consists of two parts: building an air quality management system and air pollution source control. For Beijing's air quality management system, a series of plans for air pollution control were implemented. Among these plans, the Beijing Clean Air Action Plan 2013 to 2017 was one of the most intense programs in Beijing's air pollution control history, bringing down the emission of major air pollutants in Beijing significantly. In 2017, the annual average PM2.5 concentration in Beijing fell by 35.6% from the 2013 level to 58 micrograms per cubic meter, representing a significant reduction considered challenging to achieve domestically and internationally. Beijing has also gradually built a system of local environmental economic incentive policies, which provide financial support to implement pollution control measures. The funding stood at 1.7 billion yuan in 2009 and climbed to 18.22 billion yuan in 2017. Another aspect is air pollution source control, such as energy structure optimization and coal combustion source control. Coal has long been an essential source of energy in Beijing, mainly used in sectors closely related to production and people's lives. Since 1998, Beijing has made vigorous effort to upgrade end-of-pipe treatment and adjust the energy structure, mainly concentrated in three fields: ultra-low emission renovation and clean energy alternatives in power plants, renovation of coal-fired boilers, and elimination of civil bulk coal consumption. For power plants, owing to strict EOP treatment and coal-to-gas transformation, the total PM2.5 and other pollutants emissions from power plants in Beijing continued to decline from 1998 to 2017, in spite of growing electricity production. Through the renovation of coal-fired boilers in Beijing, the annual emission of pollutants emissions in 2017 were cut by 128,500 tons in total, as compared with 1998. Other than these, policies regarding the expansion of green land have also been implemented steadily. Big data shows that the green area is increasing annually, improving air quality by absorbing pollutants and releasing fresh oxygen, providing a cleaner and healthier environment for all. In recent years, electric vehicles have emerged as a crucial factor for maintaining and further improving the city's air quality. With China's EV sales showing an 87% growth in 2022, EVs now account for 1 in 4 cars sold in the country. This growth has been encouraged by policies such as a 5% tax exemption on EV purchases until the end of 2023. Beijing's rural revitalization plan has also spurred a quicker rollout of charging stations to boost the EV market. These measures have promoted green transport and significantly reduced vehicle emissions. As more models transition to EVs and supporting infrastructures expand, the impact of this factor will likely increase in the future, contributing to continuous air quality improvement in Beijing. In conclusion, Beijing's journey towards cleaner air is a testament to the effective interplay of policy, technology, and community engagement. By addressing both natural factors and human-induced pollutions through targeted initiatives, Beijing demonstrates a modern approach to urban environmental management. As these efforts continue, Beijing will continue to offer valuable insights for other developing cities facing similar challenges.